Right now, someone near you could dig their fingers straight into your ribs, and you would howl with laughter. Try to do the exact same motion to yourself, with the exact same pressure, in the exact same spot, and almost nothing happens. Your brain sees it coming, and that single fact is about to unravel into one of the strangest stories in neuroscience, one that involves a robot arm built in a British lab, a condition where people lose the ability to tell their own touch from someone else's, and a theory that might explain why you can never truly surprise yourself. By the end of this, you will understand exactly why your own hand is the least ticklish thing in the world, and what that says about the machine running behind your eyes every second of the day. Let's start with the obvious question. What even is tickling? It feels like one thing, but scientists split it into two completely different sensations, and they don't even share the same name in research papers. The first is called Knismesis. That's the light, feathery feeling you get from a bug crawling on your arm or a hair brushing your neck. It's mild. It doesn't really make you laugh. It just makes you want to scratch the spot and get rid of whatever's there. The second is Gargalysis. This is the big one, the kind that hits your ribs, your feet, your underarms, and turns into helpless, uncontrollable laughter, sometimes even if you hate the feeling while it's happening. Gargalysis only works on certain parts of the body, and it almost always requires another person. And that detail right there is the thread we're going to pull on. Because Gargalysis needing another person isn't a coincidence. It's the entire key to this mystery. Stick with that thought, because in a few minutes it's going to connect to something happening deep in a part of your brain you've probably never heard of. For a long time, people just assumed tickling was simple. Nerve endings get triggered, brain registers touch, body reacts. Done. But that explanation falls apart the second you try to tickle yourself. If it were purely about nerves firing, self-tickling should work every single time because the exact same nerve endings are getting touched. Same pressure, same location, same speed. Nothing about the physical sensation changes, so something else has to be going on. Something upstream of the nerves. Something in the brain itself that's deciding, before you even feel it, whether this touch counts as ticklish or not. That's where things start getting strange. In the 1990s, a researcher named Sarah Blakemore, working out of University College London, decided to actually test this instead of just theorizing about it. She built a simple robotic device. It had a foam-covered arm that could brush against a person's palm, and it could be controlled either by the researcher or by the participant's own other hand moving a lever. Here's the setup. A person sits with one hand still, palm up, waiting to be touched by the robot arm. With their other hand, they control a lever that moves the robot arm. When they move the lever and the robot arm touches their palm instantly, in perfect sync with their movement, they barely feel anything. Mild. Forgettable. But when Blakemore's team added a delay, even a tiny one, somewhere between 100 and 300 milliseconds, between the lever movement and the touch, the sensation jumped. People reported it feeling more intense, more ticklish, more like something was actually happening to them instead of something they were causing. Let that sink in for a second. The physical touch didn't change. The pressure was the same. The location was the same. The only thing that changed was the timing between the action and the result. And that timing alone was enough to trick the brain into treating the touch as if it came from someone else. This is the moment researchers realized tickling isn't really about your skin at all. It's about prediction. Here's how your brain actually works behind the scenes. And this part is honestly a little unsettling once you notice it. Every single time you move any part of your body, your brain sends out two things at once. One is the actual motor command, the signal that tells your muscles what to do. The other is a copy of that command, called an efference copy, that gets sent to a different part of the brain whose entire job is prediction. That predictive system uses the efference copy to simulate, in advance, exactly what sensation is about to happen. If you're about to touch your own ribs, your brain already knows the timing, the pressure, the exact path your fingers are going to take, because it wrote the instructions. So by the time your fingers actually make contact, the brain has already prepared for it. The surprise is gone before it even arrives. Now here's the part that connects everything back to Gargalysis, the big ticklish response, and why it almost always needs a second person. A response like uncontrollable ticklish laughter seems to depend on unpredictability. Your brain needs to not know exactly when contact is coming, not know exactly where, not know exactly how hard. When another person tickles you, they don't move in the perfectly telegraphed rhythm of your own nervous system. Their timing is slightly off from what your body would predict for itself. Their pressure varies. Their path curves in ways your brain didn't pre-calculate. That gap between expectation and reality is where the reaction lives. This is why children scream with laughter when a parent or sibling tickles them, but sit there completely unfazed, poking their own stomach with the exact same finger. It's also why a stranger's tickle can feel almost intolerable while a close friend's feels playful, which hints that there's even a social and emotional layer stacked on top of the prediction system. Something we'll come back to. But before we get there, there's a piece of this story that makes the whole thing even weirder. What happens when the prediction system itself breaks? This is where things shift from playful science trivia into something genuinely eerie. There's a region tucked deep in your brain called the cerebellum, and it plays a massive role in exactly this kind of prediction and timing. Researchers using brain imaging noticed something remarkable when they compared self-touch to other touch. When people touched themselves, activity in the cerebellum actually dropped, almost like the brain had already run the simulation ahead of time and didn't need to work as hard to process what was coming. When someone else did the touching, that drop wasn't there. The brain simply hadn't rehearsed it. Now take that mechanism and imagine it malfunctioning. That's essentially what happens in a subset of people with schizophrenia. Some patients with schizophrenia report something researchers find fascinating and unsettling in equal measure. A portion of them can tickle themselves. Not everyone, and not in every study, but enough that it opened up a genuine line of research. The leading theory ties directly back to that predictive system we just talked about. If the mechanism that generates the efference copy, or the system that compares prediction to actual sensation, isn't working the way it should, the brain may fail to correctly label self-generated touch as self-generated. In some cases, this same breakdown in self-monitoring is discussed alongside symptoms like hearing voices that feel external, because in both cases, the brain's internal tagging system for what belongs to you and what doesn't isn't functioning properly. Think about how strange that is for a second. The reason you can't tickle yourself, and the reason some people with schizophrenia hear voices that feel like they're coming from outside their own head, may be rooted in a related piece of biological machinery. One system, when it works, keeps you from ever surprising yourself with your own hand. When that same kind of system falters, the brain can lose track of what's self and what's external in far more serious ways. That's the loop we opened earlier, finally starting to close. Remember how Gargalysis needed another person. Now you know why, at a level most people never think about. It's not about the skin. It's about your brain constantly running a live simulation of your own body, checking every incoming sensation against what it expected, and only reacting strongly to the ones that don't match the prediction. But there's one more twist, and it might be the most human part of this entire story. If prediction alone explained everything, then any unpredictable touch from any source should tickle you the same amount. But that's not what happens. Being tickled by someone you trust, a parent, a partner, a close friend, tends to produce a very different experience than being tickled by a stranger. With someone you trust, it often reads as playful, even joyful, despite the laughter sometimes looking like distress from the outside. With a stranger, or in a context that feels aggressive or non-consensual, that same physical action can feel closer to genuinely unpleasant, even panic-inducing. Some researchers have pointed out that ticklish laughter doesn't always mean enjoyment at all. It can be a reflexive response layered with real discomfort, which is part of why forced tickling in aggressive contexts is not actually the harmless fun it looks like on the surface. So, on top of prediction, your brain is also folding in context, relationship, safety, and intent. Two identical touches, same pressure, same spot, same timing, can produce two completely different emotional experiences depending on who's doing it and why. That means tickling sits at this strange intersection of pure biological wiring and deeply social meaning, all happening in a fraction of a second, without you ever consciously thinking about any of it. There's also a theory floating around evolutionary biology that ties this whole thing together in an even bigger way. Some researchers suggest ticklishness on places like the ribs, the neck, and the underarms, areas that are notoriously vulnerable in a physical fight, might have developed as a kind of built-in defense reflex. The instant, reflexive flinch and laughter response could be an old survival mechanism, tuned to react fast to unexpected contact near vulnerable areas, especially from something or someone that isn't you. Under that theory, the reason you can't tickle yourself isn't a flaw or a gap in the system. It's the system working exactly as intended. Your body already knows where your own hand is going. There's no threat to react to. The alarm only needs to fire when the touch is a surprise. So the next time someone tickles you and you're laughing so hard you can barely breathe, you're not just having a ticklish moment. You're watching your own nervous system in real time, running a prediction engine that has been quietly modeling your body since before you could talk, catching the one input it never planned for, and firing off a reaction that's part reflex, part social signal, and part leftover survival code from somewhere much older than either of you realize. And somewhere in your skull right now, that same system is already predicting your next move before you've even decided to make it.